Today we are going to analyze how various types of advertisements work and what kind of advertisement seems to work with what segments of population. Before we start, let me introduce my team. Here we have Angel, Lok Yung, Napasuda, Sara, and me, Christina. For this presentation, I'm going to talk about introduction and general regression. Then Napasuda is going to analyze which type of advertisements is most effectiveness. Then Angel and Sara are going to talk about the most effective type of advertisements across different demographic groups. And in the end, Lok Yung will present the conclusion. The presentation and project datasets consist of 727 total observations, but only 716 observations will be analyzed. This is because there are some unreliable data in the response, such as surface height, and surface height range from 70 to 500 centimeters. This is wrong consensus as the tallest recorded human in history measures 272 centimeters. Therefore, we only analyze the height is less than 272 centimeters. In the presentation and the project, we will divide advertisements into three groups. For the first group is about obesity, which includes Ad 1 and Ad 2. The second group is healthy diet, which is Ad 3 and Ad 4, and the third group is non-food related advertisement, which is Ad 5. In addition, in the 9 variables, attention, knowledge, diet, age, gender, weight, height, and race, we are combined weight and height into one variable, which is BMI. BMI is compares your weight and height and provide an idea of whether you are underweight, normal, overweight, and obesity. So we divide BMI into 4 groups. Less than 18.5 is underweight, 18.5 to 24.9 is normal, 25 to 29.9 is overweight, and greater than or equal to 30 is obesity. In addition, we also divide the race into 3 groups: Caucasian, Asians, and others. The others include Pacific Island, Native America, African American, and unknown. We are also divide age into 3 groups. That are Group 1 is age from 16 to 20, Group 2 is 21 to 24, and Group 3 is age greater than 25. For the general regression, the initial consumption taken by general regression is ad effectiveness is composed of how the individual evaluates thinking. Message is clear, positive, cheerfulness, and ad overall. As displayed, ad think has the largest related effect on the ad effectiveness, which is coefficient of 0.313. And the R-square value of regression is 45.2%, which means 45.2% of sample variation is explained by this linear model. The coefficient of ad positive and ad cherry has 0.271 and 0.468. which is greater than 0.05 p-values representatively. So we are deemed insignificant at 5 significance level. Therefore, we are look at the top 3 of the importance attributes, which are ad think, ad clear, and ad informational in this presentation. Now let's move to the Napasuda. She will talk about comparative advertisement.
Hi, so in this section, we conducted tests and analysis on across 5 different advertisements. As you know, each respondent will survey and ask questions based on a randomly selected advertisements. In order to compare these ads, the ANOVA test is used for comparing mean score for evaluative scores. Accordingly, we set hypotheses whether or not these ads have different mean score in each evaluative criteria. Interestingly, the result shows that the p-value is less than 0.05 and therefore rejecting the null hypothesis and accept the alternate hypothesis. Through multiple comparisons, it can be read that in the post hoc analysis, the advertisement that ranks highest in terms of its clarity of the message is ad number 3, which with a mean score of 5.58 out of 7. When comparing different ad types, it's important for us to categorize the advertisements in 3 different categories. They are obesity prevention advertisement, secondly, healthy diet advertisement, and lastly, non-food related advertisement. The advertisement that fit into the first category is ad number 1 and 2, and the second type, which aim at promoting nutritional balanced diet. There are ad number 3 and 4. And lastly, ad number 5 falls into a non-food related advertisement. When comparing different ad types, ad type 1 scores the worst all across the evaluative criteria, whereas ad type 2 has the highest mean score in all criteria. For ad type 3, which has its message that's not related to food, the p-value was rated 0.884 in a criteria of clear message. That means it's not significant, and we fail to reject the null hypothesis. In light of the comparative analysis and its interpretation, ad type 2 has outperformed the mean score in all criteria. The next highest one is ad type 3. But on the other hand, ad type 1 ranks at the bottom. This can be inferred that ads positive and cheery message can help people to react better and further drive change in lifestyle. But people tend to dislike the negative connotation of ad type 1, which is depicted by its graphical content about obesity. It has even lower score than ad type 3, which has a neutral view regarding food and health.
Based on the result from the previous test, we know that ad type 2 outperformed the rest of the sample size in every evaluation criteria groups. Therefore, in this session, we are going to focus on analyzing ad type 2 evaluations against ad type 1 and 3 across different demographic groups. For the sex analysis across the female population, we found that every evaluative criteria had a statistically different means between ad types, while across the male population, ad message is clear is excluded. Both female and male had rated ad type 2 the highest effectiveness. Ad type 2 is also scored the highest means in every evaluative criteria out of any ad types. Furthermore, independent sample t-tests had also proved that there was no difference in means between males and females for any evaluative criteria. Therefore, sex is not a statistically differentiable factor when evaluating any criteria for ad type 2, but it is most effective for both sexes. For the age group analysis, people within 16 to 20 years old, we found that every evaluative criteria had statistically different means between ad types. Ad type 2 makes this age group think more and is perceived as more informational than the other ad types. Similar trends were also found in the 21 to 24 and 25 or above age groups, where type 2 ads consistently found to be more informational, effective, and thoughtful. According to the NANOVA, we found that there was no difference in means among age group in ad type 2. However, on the overall sample, it was found that ad is positive and ad is cherry differed by ad types, specifically with 25 or above age group. Therefore, age groups are not statistically differentiable when evaluating any ad criteria in ad type 2, but in overall sample, 25 or above age group tends to rate ad as more cheerful and positive than counterparts groups. Yeah. For the race analysis, Caucasians were found to have statistically different means between ad types for every evaluative criteria, except ad message is clear. They rated ad type 2 the highest effectiveness, informational, and thoughtful. Asians and others were found to have similar trends to Caucasian in response to type 2 ads, with statistically different means in ANOVA for every evaluative criteria. Most of the Asians found ad type 2 more informational and thoughtful than ad type 1. Overall, there is a consistency where every race group finds type 2 ads the most effective, followed by type 3 and then type 1. Also, Caucasians in the overall sample put more thought into viewing the ads, which possibly explains why they find ads more informational than others. For the English analysis, people whose first language was English, all evaluation criteria had difference in means between ad, except ad message is clear, while those whose first language was not English had statistically difference in means for all evaluative criteria. Both segments rate ad type 2 is more effective than ad type 1 and 3. However, it was found that they had no statistically difference in rating ads when comparing between them. Therefore, regardless of first language English-speaking background, both segments rate type 2 ads higher in every evaluative criteria in the same way.
Following what Angel has mentioned, now we are going to move to the demographic variables of BMI, diet, attention, and knowledge, and to see whether the average rating of evaluative variables in each segment differ by ad type. Firstly, for BMI, we have conducted a ANOVA test for different BMI groups. The result shows that within BMI group healthy and obese, the respondent rates the evaluative variables differ by ad type. On the other hand, for BMI group overweight and underweight, the ANOVA suggests that respondent rates all evaluative variables differ by ad type except ad makes me think and ad is effective. Although there is a difference in how BMI group evaluate the effectiveness of different ad types, this does not mean that different BMI group rates the ad differently from each other. Now we're going to look at the segment of those who has a special diet to improve health and those who don't. The ANOVA results suggest that those who have a special diet would rate ad type 2 a higher of 1.33 score in effectiveness than in ad type 1, and a higher of 0.04 than in ad type 3. For those who are not on special diet, ANOVA test suggests similar results. As we can see on screen, we can see that those who are not on special diet would rate 1.25 higher in effectiveness in ad type 2 than type 1. Also, they would rate a higher of 0.84 in effectiveness in ad type 2 than type 3. As a result, it can be concluded that both of those who are on special diet and those who don't find ad type 2 more effective than the other ads, as the ANOVA mean was found to be higher than other ad types. The last ANOVA test was conducted on the segment of attention to nutrition labels. For those who pay attention to nutrition labels, the two-key test result highlights that there is a higher of 1.45 score in effectiveness in ad type 2 than type 1, and there is a higher of 0.93 in effectiveness score for ad type 2 than type 3, as shown on the screen. This suggests that for those who pay attention to nutrition labels, find ad type 2 more effective in comparison to other ad types. A similar test was done for those who do not pay attention to nutrition labels. The two-key test results again highlights that a higher of 0.96 in effectiveness score in ad type 2 than type 1, and a higher of 0.692 in effectiveness score in ad type 2 than type 3. To conclude, both the respondents who pay attention to nutrition labels and those who don't find ad type 2 more effective on average according to the results. The last demographic variables that we're going to test today is knowledge about food and nutrition. We have conducted a correlation for knowledge and the evaluative variables because knowledge is a scale variable. From the correlation table on the screen, the Pearson correlation figure for the evaluative variables are greater than 0.2. Although there are significant results can be found for some of the evaluative variables, for example, ad makes me think, the Pearson correlation suggests rather weak relationship, which can be deemed that there is no relationship at all.
So we arrive at deficiency issues and social policy making implications. The small sample size was a constraint that restricted our flexibility to use more complex statistical methods for analysis. there is inevitable omitted variable bias. As with all studies that model human behavior, it is impossible to include every relevant predictor variable to the regression. The elusiveness of the perfect model is due to financial or time constraints in real-life scenarios. There was a deficiency where there was an overrepresentation of Asians in the sample, nearing 69%. This compromises the inferences drawn from any analysis on race segments. This overrepresentation appears to be unintentional, as the study is not focused on Asians specifically and could be from unintentional selection bias. The knowledge variable was subjective to the surveyed individual. Reliable survey metrics should be as objective as possible and minimize subjectivity, but the metric itself is deficient as it is too generalized for gaining statistical validity. The age distribution was positively skewed towards the 16 to 25 age group, nearing 87% of all observations. This also appears to be unintentional selection bias, as the study was not focused on adolescents. The body mass index groups did not follow an approximate even distribution. With only 33 obese people surveyed, the results obtained in the upper tail were unlikely to be reliable. The findings from our report have strong implications on social policy. It is clear that Ad3 was the most effective in every evaluative criteria. Type 2 ads were the most effective type. From a marketer's perspective, using Ad3 is better across all demographics and segments. Promoting healthy diet is more effective than influencing and scaring people about obesity. So now we know which ad works the best. For future research, we need to now ask the right questions. Why is Ad3 the best and Ad1 the worst? This can be researched using focus groups to obtain opinions from the population. Concluding these studies, we found answers, but are left with even more questions. Future research can dig deeper. What are common traits in successful ads? Do these findings change over time? Are these findings specific to Australia? These are all avenues for future discovery. Thank you.